Welcome to Capturing Christianity. Has Dr. Craig's argument from the applicability of mathematics been debunked? That's what we're talking about today. I've got Dr. William Lane Craig here with me, back on the channel. He's been on a bunch lately, and he's back to respond to some of the things that Stephen Woodford from Rationality Rules has said in response to Dr. Craig's argument that would you agree that you're kind of toying around with this argument, with the argument from the applicability of mathematics?
I would say that that's true in the past, but having worked on it over the past year, I am now convinced that this is one of the most powerful arguments for God's existence that I've encountered.
Wow, that's really cool. So one of the issues for me is that the argument from mathematics, the applicability of mathematics, is a little bit more difficult to just wrap my mind around. The argument from fine-tuning, that one seems a little bit easier. The argument from contingency, the Kalam cosmological argument, those arguments were relatively easy to grasp, but this one just takes, I think, a lot more work to really understand how it works, what are some of the moves that are being made. So that's been one of the struggles for me, is that it's just a little bit more difficult to just understand how it works.
I think part of the difficulty is that different people understand it in different ways. And as a result, people are talking past each other because there can be different versions of this argument.
That makes a lot of sense. All right. Well, is there anything that you'd like to say as we get started into responding to some of the things that he said in his video? Is there any sort of overall views that you have on the video itself before we start playing some of these clips?
Well, I was gratified to find a YouTube personality that is ironic and respectful in his criticism. That's the kind of person that I enjoy interacting with. And so although I disagree with Stephen's views, I'm grateful for the charitable spirit in which he offers his critique.
I also wanted to mention that at the time, as of this recording, his video has 71,000 views in just 4 weeks, which is pretty good on YouTube, and especially in this area, apologetics. Some of the videos that we put out, I mean, even a channel our size, which we're coming up on 60,000 subscribers, some of our videos still only get a handful of thousand views. And to me, that's really good. I think that's a lot of views. But for someone like him, who's publishing a video on this very esoteric argument for God's existence, to get 71,000 views, I think that's really cool. And I think that's a good reason to provide some kind of response to it. So that's one of the reasons why we're doing this.
I do too, Cameron. And I must say, this has caught us all by surprise. When we produced this Sangmeister video on the applicability of mathematics, I never dreamt that it would elicit the sort of interest that it has. But you and others are talking about it, and people are going to videos to think about it. Somehow, this has just really captured the imagination of people.
Yeah, I think that's really cool too. Okay, well, so before we play the first clip, there's actually one of the first objections that he has, and I don't have this clip pulled up to play and respond to, but one of his first objections that he gets into right at the beginning of his video is he says Dr. Craig doesn't define what he means. This is not an exact quote or anything, but this is basically his first objection, is that Dr. Craig doesn't define what he means by mathematics, and defining terms is paramount in doing good philosophy. So how do you respond to that?
I would say that there is no consensus about a definition of the field of mathematics. So it's hardly surprising that one would not offer a definition. Mathematics is an abstract study of quantity, of spatial relations, of abstract structures, of change. And it is a wide-ranging discipline that is very a priori in its nature, not empirically based, but based purely in rational investigation. And I noticed that Stephen, for his part, didn't offer any definition of mathematics either. So if it's so crucial to the question, I was puzzled that he didn't himself give a definition. The fact is that this is one of those broad disciplines that resists any kind of consensus definition.
I wonder if you could also, so I have two thoughts. I wonder if you could also just treat mathematics, and I'm going to use a philosophical term, as a primitive. So you wouldn't necessarily need to give a definition. Some people do that with knowledge and some other certain terms that are kind of tricky and difficult to define. So that's one way that you could respond. Go ahead.
Yes, I saw one person define it by saying mathematics is what mathematicians do. And that's sort of in line with what you're saying. In any case, I think he's quite incorrect that you need to have a definition of mathematics in order for Wigner's argument to get off the ground, because what Wigner is talking about is fairly clear. He's talking about the laws of the physical phenomena, which have mathematical expression in the terms of elegant equations that describe the physical phenomena to an astounding degree of accuracy. And there's a good understanding of what one is talking about when one speaks of such natural laws.
Yeah, the other thought that I had was in a video. So what Stephen did is he responded to a 5-minute animated video that is meant to be, it's on the popular level. Obviously, it's animated. It's meant to just sort of get the argument out there and get people thinking and talking and everything, and maybe even push them to go deeper into the argument. So I think we would expect to have to cut down in certain areas. So it's not to me a really big objection to this video in particular, that you're not going to define every term. I mean, there's a lot of terms in the video that are left undefined, and I think that's just because of sort of the nature of what this video was, is that it wasn't an academic lecture, 45-minute lecture given at a university. This is a 5-minute animated video that's just going to give a cursory look at this argument.
Sure. That's exactly right, Cameron. And near the end of his video clip, Stephen says to me, will somebody explain to me what I'm missing about this? And I think there are two things that he's missing.
Why don't we play that clip? Because I have it queued up here.
All right.
We'll play the clip and then we'll get your response to it. Here we go.
Dr. Craig is very often presented as a theist of strong intellectual stature, and I have to say, I'm someone who shares this notion. Craig has challenged me, in fact, more than any other theist I've read, but his argumentation here strikes me as jarringly poor. By assuming that the properties of the universe are built upon mathematics, rather than that mathematics is built upon the properties of the universe, Craig has put the cart before the horse. His argument is essentially a reskin of presuppositionalism, in which he's replaced the laws of logic with the axioms of mathematics. Now, to ensure that Craig's specific presentation here isn't simply a weak rendition, I've listened to him debating the philosopher Dr. Graham Oppy on this very argument, and I've digested just about every video on YouTube I can find of him discussing the topic. But I found nothing of greater substance than what's found in this short, polished presentation.
Take mystery number one, the applicability of mathematics. I think this is a huge issue.
If I'm honest, this is the kind of argument I'd expect from the likes of Frank Turek, as opposed to Craig. Because of this, I can't help but knock the feeling that I'm missing something. So if any of you think that I am, then please do let me know and I'll make another video.
Here's your opportunity.
I think he's missing two things. First, he hasn't digested Wigner's original article on the unreasonable effectiveness of mathematics. When you look at Stephen's critique, he actually has very little to say about my theistic explanation for the applicability of mathematics. Most of his criticisms are aimed at Wigner's argument that the effectiveness of mathematics in describing the physical phenomena is something that is surprising and unexpected and cries out for explanation. And so his real disagreement is primarily with Wigner, and yet he doesn't interact with Wigner's discussion of this problem. Wigner refutes virtually all of the objections that Stephen raises in the video. The presentation by Wigner is brilliant, so that anybody who wants to deal with these issues has got to digest thoroughly Eugene Wigner's original article. Now, the second thing that Stephen is missing, through no fault of his own, is my scholarly article on this subject called God and the Applicability of Mathematics, which is forthcoming in a book edited by Colin Ruloff on arguments in natural theology. And in this article, I lay out in great detail Wigner's argument, consider objections to it, and have a thorough discussion of it. So when this appears later this year, this would be something I think that Stephen would need to digest as well. The 5-minute video is popularization of this on the level of a high school senior, and therefore cannot be a complete and academic discussion of Wigner's argument.
So what are your thoughts on one of the other things that he said, that your argument seemed almost like presuppositionalism? Where did that come from?
I don't know, Cameron. I mean, that's just a bizarre comparison. Maybe for our listeners, we should explain. Presuppositionalism is a school of apologetics that says the way you should defend the Christian worldview is you presuppose its truth, and then on the basis of those presuppositions, you argue for its truth, which is reasoning in a circle. And I don't see any similarity between Wigner's argument and presuppositionalism in apologetics. What Wigner is saying is that the effectiveness of mathematics in describing the physical phenomena is surprising. It's unexpected, and therefore cries out for some sort of explanation. And my argument is that positing a divine mind behind the universe is the best explanation for the uncanny effectiveness of mathematics in the physical world. So this is an inference to the best explanation. It's not presuppositionalism. Ed Witten, the eminent theoretical physicist, in an interview with Robert Kuhn on the effectiveness of mathematics, says it's as if the creator of the universe were a mathematician. And I think that really encapsulates the argument here that I'm giving.
Yeah, if we can, I want to spend a couple minutes just thinking about what does it mean to say that the universe, or that that mathematics is applicable or effective. What does that actually mean? So I think it could be interpreted a couple ways, and this is one of the reasons why it's difficult to get my mind wrapped around what the concept here is. Is it just because it almost sounds like this argument can collapse into like a fine-tuning argument to say that the world could have been a number of ways, and this way that it is, and the fine-tuning argument for life is typically framed in terms of like there's a small subset of possible ways that the universe could have been that allow for the evolution of life, but it's this evidence that the universe can sustain life is more expected under theism than it is under something like naturalism, or so that. Is that kind of the same? Is this kind of the same argument as like a fine-tuning argument?
I don't think it is. I don't think so. I mean, the similarities are that they both concern the mathematical laws of nature. But the one asks, why is it that the fundamental constants and quantities exhibited in the laws of nature are life-permitting rather than life-prohibiting, when it's incomprehensibly more probable that they should be life prohibiting? This argument rather says that mathematics is an a priori science concerning abstract objects, which even if they exist, have no causal connection to the physical world. And so what is the explanation for why mathematics is so applicable to the physical world? That is to say, why is it that the fundamental physical laws of nature are formulable as these elegant mathematical equations, given that mathematics is a priori, that is to say, non-empirical and causally unconnected to the physical world?
So I guess here's my question. What would the alternative look like? How would you have a world that is not, that you can't describe mathematically? See, that to me, I just can't wrap my mind around that.
Well, think of a chaos, for example. Albert Einstein, in talking about this, said one would rather expect the world to be just a chaos in which there were no mathematical laws of nature that describe the phenomena. Or one might
no
think
regularities.
Right. Well, or one might think that even if the universe were not a chaos, that the universe would be described by extremely primitive mathematical truths, like, say, arithmetic, that one boulder and one boulder make two boulders, for example, but would not have the kind of elegant mathematics that Wigner talks about in general relativity theory and quantum mechanics. So those would be alternatives, very simple or primitive laws or no laws at all, rather than the mathematically elegant formulae that describe so accurately the physical phenomena.
All right, let's get to our second clip, and this one is from Stephen explaining why he thinks that mathematics is so effective. Here we go.
Think about it. Mathematical entities like numbers, sets, and equations are non-physical and abstract. They can't cause anything. Yet, for some reason, the physical universe operates mathematically.
Mathematical entities such as the aforementioned are non-physical and abstract, yes, but the things they were invented to refer to are not. The earliest signs of Homo sapiens exercising mathematics dates back at least 5,000 years to the kingdoms of Mesopotamia and ancient Egypt, in which arithmetic, algebra, and geometry were employed for the purposes of trade, commerce, astronomy, and taxation. As a proponent of the non-Platonic view of mathematics known as Logicism, I would thus argue that mathematics is an expression of logic that holds only so much as its axioms correlate with reality. To answer the opening question through this prism, mathematics works because that is precisely what we've designed it to do. So much so, in fact, that when it doesn't work, which is to say when it doesn't correlate with reality, we alter its axioms so that it does. To ask why is mathematics so unreasonably effective is to ask why is reason so unreasonably effective.
Now, this is a self-contradictory mishmash of different positions that I don't think Stephen has thought through very well. Do you notice he says at first that he's defending logicism, that mathematics is an extension of logic? Now, logicism was a program adopted by Bertrand Russell and Alfred North Whitehead in their epical book Principia Mathematica, in which they tried to derive mathematics from pure logic, so that the truths of mathematics would be logical truths, not truths that we make up or are conventional, but they're logically necessary. And this program by Russell and Whitehead failed because mathematics involves certain existential statements, like the infinite set axiom, that there exists a set with an infinite number of members. No existential statement can be truth of pure logic. And therefore, logicism failed to show that you could regard mathematics as simply an extension of logic. But on this view, you see, mathematics is taken to be a body of logically necessary truths. Now, that's completely contradictory with what Stephen then goes on to describe as a conventionalist view of mathematics. This is a kind of postmodernist view that is in such a minority that it's not even discussed in the little video because one doesn't have time. The conventionalist says that basically mathematical truths are just made up. They're just invented. We impose them on reality, or in Stephen's view, we simply keep revising our mathematical truths so that they will correspond to reality. And that contradicts his logicism, which regards mathematical truths as necessary truths. Moreover, what he says there in defense of a kind of conventionalist view is just patently false. The whole point of Wigner's argument is that mathematics is an a priori science that is pursued for what he calls aesthetic reasons, reasons related to mathematical beauty and excellence, whether it has any physical application or not. And in the video, we point out that many mathematical concepts like Hilbert space, which is infinite dimensional space, or imaginary numbers, which have great applicability in describing physical phenomena, cannot be realized in the physical world. These are not read off of the physical universe. So it's quite incorrect to say that mathematics is revised when it doesn't fit reality. I think that Stephen is confusing mathematics with natural laws. What happens when the natural laws prove that to be non-descriptive of reality is you revise the natural law. You get a better law, a more accurate law, but you don't revise mathematics.
I'm thinking
Newton's.
you were just about to say it.
When Newton's physics were abandoned for relativistic theories, we didn't give up calculus. The mathematics wasn't revised. You didn't revise calculus. Rather, what was revised was the gravitational theory that describes the universe. So the mathematics remains constant, but what is revised will be the natural laws descriptive of the physical phenomena.
Yeah, you just gave the example that I was thinking of from Newtonian mechanics to general relativity, which, by the way, if you guys want to understand what the difference is and how all that works and why it's even relevant to this whole discussion, watch the breakdown that I did with David Hutchings on Dr. Craig's discussion that he had with Dr. Graham Oppie on our channel. We did a breakdown of explain it like I'm five version of that debate, which was very, very intellectual, it was very, very high level stuff. And so we did a breakdown of it so that everybody could understand. And we even broke down, or David did, he broke down the difference between Newtonian mechanics and general relativity and the way that those interact, because that actually came up in the debate too. So I just want to make people aware of that. Now, a question I have for you, Dr. Craig, is one of the things you said was that his logicism was inconsistent with conventionalism. Do you think that there is any way to make those compatible, or is it just
no? Okay. There isn't. They're polar opposites. Logicism says that mathematics is a body of necessary truths, like the truths of logic, and conventionalism says that these are just human conventions. We just made them up. So these are, and that they could be arbitrarily revised otherwise. So these are polar opposites in terms of their view of mathematics.
I see.
And scarcely anybody holds to conventionalism. You ask any theoretical physicist or mathematician as to whether the universe we live in really is describable by elegant mathematical equations, and they will say, of course it is. You wouldn't be fooling around with nuclear reactors and atom smashers if these mathematical formula didn't give you a correct description of the physical universe. If they didn't, you would be in danger of blowing yourself to bits.
All right, let's move on to our third clip that we have set to play here. And this is, he says that you misrepresent Davies' views because Davies admits, Paul Davies admits that he's in the minority. And so we're going to watch that clip, and then we have something special planned for that. So here we go.
As Galileo put it, the book of nature is written in the language of mathematics. Scientists do not use mathematics merely as a convenient way of organizing the data. They believe that mathematical relationships reflect real aspects of the physical world.
As already mentioned, mathematicians are far from united in their views of what mathematics is, let alone what its relationship is to the physical world. To build his narrative of mathematics being miraculous, Craig is careful to only quote mathematicians who share his view, and in doing so his presentation heavily gives the impression that mathematics is discovered as opposed to invented. To bolster this point, here's Paul Davies, the physicist that Craig has just quoted, owning the fact that his views are a minority among the scientific community.
And in that view, you are distinctly in the minority among at least the physicists and mathematicians and scientists that I know.
Right.
And you don't deny that you're in that minority in that thinking, a place that you apparently like to inhabit.
Yes, I freely admit that most of my colleagues would not agree with me.
Whereas the last objection was purely of Craig's presentation, this objection is against both his presentation and argument. Craig spends the bulk of his presentation selling the false impression that scientists, mathematicians and physicists can't provide a naturalistic account of mathematics, which is vital for his argument to work. If mathematics is not miraculous, his argument is baffling.
Go ahead.
When Robert Kuhn says, in that view, you are in the distinct minority, my antenna immediately went up because that statement is taken out of context. What is the view that Kuhn is referring to when he says, in that view? Well, when you watch the original clip, what you find out is that it is Stephen who is the one that is either misunderstanding or misrepresenting Paul Davies' view, because the view that Davies is talking about is the problem of how is it that the human mind has evolved so that we are able to grasp these complex mathematical equations that govern the universe. This is a very different concern than Wigner tackles in his article. Davies' concern is with how a monkey's mind, as it were, evolving for survival value, would come to be able to grasp these elegant mathematical truths, which are certainly not necessary for survival. And so Davies' argument is that there must be some sort of a pre-established harmony between the human mind, and he emphasizes not the brain, the mind, between the human mind and the mathematical structure of the world, such that the mind is able to grasp this structure. Well, without wanting to in any way belittle Davies' argument, I would simply say it's very evident that that's not Wigner's concern. And that's not the argument presented in the video. This is a totally different argument in which Davies says he's in the minority in thinking that there is a kind of harmony between mind and mathematics that characterizes the world. So Stephen, he really, this was foolish of him to quote a video out of context that everyone can go online and look at. His criticism about my video misrepresenting him or things really comes back to bite him here, I think.
Yeah, and we're about to see. I've got actually the context that comes before and after the quote that he put in his video. So we're going to watch it for ourselves, and we're going to see that Dr. Craig is actually right here. So let's play the video.
Why is it that this species, Homo sapiens, has evolved the capability of doing this type of abstract reasoning and doing these mathematical procedures, some of which are quite hard, in a way that is so extraordinarily effective in grasping the nature of so many physical phenomena? Now, a lot of people just shrug this aside, but I don't think there's anything in our evolutionary history that compels human beings to develop the cognitive architecture necessary to do this. Our brains, our minds have evolved, like our bodies, to survive in the proverbial jungle. And so, of course, it would be useful to be able to count and work out angles and so on. But there's absolutely no reason why we should have the level of mathematics necessary to explain, for example, the nature of black holes or the structure of the hydrogen atom or anything like that. These are things beyond any sort of reasonable survival value. So is it just a coincidence that the mathematics that we evolved to cope with just for basic survival also just happens to work so well in so many areas of reality? I don't believe in coincidences like that. I think it means that the human mind has evolved, and the mind, not the brain, I'm talking about the human mind has evolved to somehow mirror the nature of reality in a very deep way. I think it's a non-trivial fact. It sounds a little bit mystical. It sounds like somehow we are meant to be here, or that we are players in the great cosmic drama in this very fundamental way. yes, I think we are, and it's one of these facts that I regard as giving huge significance to human life. A lot of people think significance in human life is what I do in my daily life and living a good life, being a good person. And I think an even deeper significance is the fact that we're plugged in to that deep level of reality through mathematics.
And in that view, you are distinctly in the minority among at least the physicists and mathematicians and scientists that I know.
Right.
You don't deny that you're in that minority in that thinking, a place that you apparently like to inhabit.
Yes, I freely admit that most of my colleagues would not agree with me. On the other hand, they don't give very coherent accounts of why mathematics is so useful in physics either. And so I often will provoke them by saying things like, well, where did the laws of physics come from and why do they have this elegant mathematical form that they do? And they really don't have an answer to that.
Now, what's really interesting, Cameron, about that clip from Davies is that he begins by talking about his evolutionary argument and how the mind is able to grasp this. But then at the end, in response to Kuhn, his argument does morph into Wigner's argument when he says, I ask my colleagues, what is the explanation for why the universe is characterized by these elegant physical laws? And he says, they have no answer for me. And that's exactly what Wigner said. He said, it's just a miracle, which we don't understand or deserve. And so the naturalist is really left quite puzzled here.
All right, well, let's move to the next clip here. So this next clip, basically Stephen says that the definition of miracle, you're kind of misleading on that in the video, and you also the video implies that Wigner is a theist when actually he's an atheist. So let's watch this clip and get your response to it.
How do we explain the astonishing applicability of math to the physical world? In 1960, the Nobel Prize-winning physicist and mathematician Eugene Wigner published an article that stunned the scientific community entitled The Unreasonable Effectiveness of Mathematics in the Natural Sciences. Wigner concluded that the effectiveness of mathematics is a miracle, which we neither understand nor deserve.
Wigner's article was, and indeed still is, contentious among mathematicians, largely due to there being so many schools of thought. But it's my opinion that Craig, in his theological fervour, does Wigner two disservices. The first is that he misappropriates Wigner's words to fit the narrative of mathematics being a miracle in the divine sense of the word, as opposed to the extraordinarily welcome sense of the word. Within his short article, Wigner uses the word miracle 12 times, as he considers, for instance, the fact that we can predict anything in the future to be a miracle. And he compares the miracle of mathematics playing a role in quantum theory to the miracle that the human mind can string 1,000 arguments together without getting into contradictions. And the second disservice I believe Craig does to Wigner is that by so misappropriating his words, Craig gives the impression that Wigner was a theist, when in fact he was an atheist.
What's your response to that?
I certainly didn't mean to give that impression. As I say in my scholarly article on this, I do a detailed exegesis of Wigner's article. And when Wigner says it's a miracle, what he means as a naturalist is that it's inexplicable. He just throws up his hands and says, we can't explain the uncanny effectiveness of mathematics. But what I argue in the article and then also in the video at the end is that Wigner, in saying this, spoke better than he knew. That in fact, the applicability of mathematics is literally a miracle. And that's the word that I add in at the end of the video, that it is literally a miracle. That is to say, it is wrought by God, and that therefore the applicability of mathematics is an argument for the existence of God. Now, certainly, I don't mean to suggest that Wigner himself was a theist or that he understood miracle that way, but I do think that he spoke better than he knew when he said that the applicability of mathematics to the physical world is a miracle.
Yeah, I also want to point out one more time that, again, this is a 5-minute introductory video, and we can't expect Dr. Craig or the Reasonable Faith team to go into all of the details and give all of these caveats. You know, he could have said and added however many seconds to the video, another 5 or 10 seconds. Oh, and by the way, Wigner is an atheist. If that didn't serve some explicit purpose, then in a short 5-minute video that's meant to just explain an argument, you wouldn't expect to have these little caveats and these little explanations and go into all of these little details. That's what an animated video, 5-minute video is. It's an introduction that contains the bare minimum of the information that you need in order to understand the argument. So this objection, I think, is kind of
the article.
Yeah, it's just the
and in fact, you know, Wigner's being a naturalist is actually to my advantage. If you've noticed in my arguments for God's existence, I love to quote from people like Alex Vilenkin and Richard Dawkins, and in this case, Eugene Wigner, because then I can't be accused of having an axe to grind. These are the best secular thinkers who are telling us that the universe, say, began to exist and there needs to be an explanation for this, or that the fine-tuning of the universe cries out for explanation, or that the applicability of mathematics to the physical world is unexpected and demands an explanation. It's the very fact that these are naturalists that are saying this and not theists, I think redounds to the tremendous power of these arguments.
Yeah, and that's also just a good persuasive technique, is to use people that are not in your camp that nevertheless agree with this particular point that you're making. It's just a great way to argue and give a presentation. Okay, let's move on to clip number 5, where Stephen argues that Craig has not shown that math is miraculous. Here we go.
Craig has not demonstrated that the effectiveness of mathematics is miraculous. The reason that mathematics is so unreasonably effective is the same reason that reason is so unreasonably effective. It's because 1, when it's not effective, we alter its axioms so that it is, and 2, the universe is fairly consistent, and so it's no surprise that the tools that we created for our own environment happen to be applicable to other environments.
Here again, you have this really inconsistent mishmash of Logicism and conventionalism. He seems to affirm that mathematics is effective because reason is effective. That is to say, these are logically necessary truths. But then he turns around and says that if they don't work, then we revise them. Well, you don't revise the laws of logic or the theorems of mathematics. The conventionalist thesis is incompatible with seeing the explanation of mathematics to lie in their logical necessity. And then Cameron, at the end of that clip, he pulls in yet another consideration that confuses the picture even more, and that is, why do the laws of nature that so effectively describe our local vicinity in the universe apply to distant areas of the universe that we don't have any immediate contact with? And he's confident there that given the orderly nature of the universe, the laws that we observe here also apply there. Well, I hope our viewers can see that, again, is a very different question than the applicability of mathematics to the physical phenomena. There, Stephen is concerned with whether or not the laws of nature that we have discovered apply not only locally, but universally. And that's just a very different question. And so, again, I honestly think that Stephen hasn't understood Wigner's argument. I believe that he thinks the argument is, or the question is, why is it that the laws of nature which we discover are so accurate in describing the physical world? And his answer is, well, because we make the laws of nature to describe the physical world. We craft them and work on them until they describe the physical world. And that's just not Wigner's question. Of course, the laws of nature are constantly revisable with the progress of science. You revise the laws to describe reality, but it's not the mathematics that's revised. As we said before, with the transition from Newtonian physics to relativistic physics. You don't give up the calculus.
Yeah, I think that you're on to something too about his view. Whatever his view is, there seems to be an inconsistency there, because he says that in one part of the video he affirms logicism, and then the next part it seems like he's affirming something like conventionalism, and so there does seem to be some tension there. If anything, even if you don't want to say it's explicitly contradictory, there is a lot of tension there, and so I think he's got some work to do, some work ahead of him to figure out what his view actually is. And
whether or not he's even asking the same question that Wigner is. Again, the question is not, why is it that the laws of nature that we formulate are so accurate in describing the physical world? That's not the question.
Another thing I wanted to pick up on in this little clip was he says one of the criteria that he gives in order to explain the effectiveness of mathematics. The second one is the universe is fairly consistent, and so there he's pointing to regularity. And when you explained what the argument actually looks like earlier, and I said, well, what's the alternative? And you said chaos. And so what he's appealing to here is basically the evidence in need of explanation. To explain, yeah. So it's like
that's right, Cameron. And if you watch his video, he gives a number of quotations from Robert Kuhn's interviews with other theoretical physicists about the applicability of the laws of nature, including people like Steven Weinberg. And if you listen carefully to what they say, all of those physicists tell Kuhn that, in fact, the universe is describable by these elegant mathematical laws. And they don't offer any explanation for that fact, and they all agree with that fact. So again, I think Stephen is barking up the wrong tree. When he talks about the consistency of the universe, I think that he's raising the question that in astrophysics is called the Copernican principle, which is that the same laws of nature that govern our local physics are also governing distant realms of the universe. And he's saying the universe is consistent, so the laws that hold here also hold there. I agree, but that's just not Wigner's question.
All right, let's get to another clip here. And this one, he says that your definition of a naturalist is uncharitable. Let's watch this one.
Why is mathematics so effective? Philosophers who address this question fall into two camps. Naturalists, who believe that all that exists concretely is space-time and its physical contents. They exclude supernatural causes. And theists, who believe in a God who created the universe.
The definition of naturalism, like mathematics, is hotly debated, and the one that Craig presents is as uncharitable as to define Christians as those who believe in creationism and a young earth. A more charitable, and indeed accurate definition of a naturalist, is one who believes that the laws and forces of the universe are entirely governed by natural as opposed to supernatural regulations. Predictive mathematics, ironically enough, depends on naturalism. Our predictions are predicated on the consistency of the laws of nature, and a supernatural intervention would violate our predictions since we would not have accounted for it.
Yeah, so I want to, before you respond, I want to just reiterate the two sort of points that he made here, and I think it's important to respond to these. So the first one is that he says your definition of naturalist is uncharitable. He doesn't give a reason for why he thinks that. He just sort of asserts that. But he says that, and then he gives his definition of a naturalist, and he says a naturalist is one who believes that the laws and forces of the universe are governed entirely by natural as opposed to supernatural regulations. What does that mean? So it sounds like he's giving a circular definition here. It could go like this. A naturalist is one who believes that the laws of nature are governed by the laws of nature. That's almost sounds like what he's saying a naturalist believes.
Well, in the video, we give two theses that characterize the naturalistic worldview. One is that all that exists is space-time and its physical contents. And then the second thesis is that there are no supernatural causes of events in the world. And what Stephen, in effect, does, I think, is to eliminate the first one and just hold to the second one. When he says that everything is describable by natural law and physical causes, that just is the second thesis, that there are no supernatural causes of things in the world. Now, why is that the case? If God exists, if supernatural entities exist, why is it the case that there are no supernatural causes? Well, the reason is because naturalists typically believe that no such supernatural entities exist. That is to say, they accept the first thesis, that all that exists is space-time and its physical contents, and therefore there are no supernatural causes. And far from being uncharitable, this is a standard definition of naturalism that is given by naturalists themselves. So I think he's just entirely mistaken in thinking that this definition is either inaccurate or uncharitable.
Yep. And then the second thing that he does is he gives an argument, which is it's an interesting argument. I'll give it that. He says why mathematics depends on naturalism. This is his argument. Our predictions are predicated on the consistency of the laws of nature, and a supernatural intervention would violate our predictions since we would not have accounted for it. And so he says that basically in order to make predictions, we've got to assume naturalism.
That's the shadow of David Hume hanging over him, thinking that miracles are violations of the laws of nature and are therefore impossible, or that if a miracle occurred, a natural law would be violated. And here I would just refer to the extensive literature and philosophy on the problem of miracles. I think that's a prejudicial characterization of what a miracle is. I think that the laws of nature have implicit in them what are called ceteris paribus conditions, that is to say, all things being equal. So the law of nature states what will happen, all things being equal. But of course, if there were a supernatural intervention, then what is predicted might not occur. But those supernatural interventions don't violate the laws of nature, because the statement of the law is a statement of what would or will happen, all things being equal. So it's really quite prejudicial to characterize miracles as violations of nature's laws.
Yep. And here's one last thing to make on this point, is that he argues that naturalism is the only real reasonable way to account for regularity in nature. And I just want to point out that a naturalist actually has a difficult time accounting for regularity in nature, partly because what would we expect if, just suppose that naturalism were true, that there were no supernatural agents influencing any laws or anything? Would we expect a universe that is regular, that has consistency over time, and is orderly? Is that the kind of universe that we would expect? I don't think so. I think, just like you mentioned at the very beginning of this, kind of going back to the argument, is that on naturalism, there's no real reason to expect an ordered universe over a chaotic universe. And so when you want to appeal to regularity in nature, theism actually provides some predictive power here that naturalism doesn't. Here's one reason. This comes from a guy named Richard Swinburne. He's one of the most brilliant natural theologians to, I think, have ever existed. He's just brilliant. He's still alive. I've interviewed him on my channel. Here's what he says, is basically on theism, you would expect God to create moral agents like us, people who are able to make moral decisions. We can choose between right and wrong. But what's required for a moral agent to actually make these types of decisions? We've got to weigh our actions. We've got to be able to see into the future and think, if I wave my hand like this with a knife in my hand, that's going to cause harm to this person. That requires regularity. And so in order to have moral agents, which is a good thing, moral agents are a good thing to exist. We have a lot of value. I think my daughter is more valuable than my house, for example. Moral agents are valuable things. In order to have those things, you've got to have regularity. And so on theism, Richard Swinburne argues, we actually have a whole lot of reason to expect regularity in nature because it's required in order for moral agency. But think about the alternative again, back to naturalism. Why would we expect regularity on naturalism? There's no real reason to expect an ordered universe rather than just a universe that's described by chaos, or not even really descriptive by language at all. There's no real reason to expect regularity. And so I think this point actually comes back to bite him. Do you have anything to add on that?
Okay. No, I think that was well spoken.
Thank you. All right, so I'm going to skip the clip that we have of Hassenfelder, Weinberg, and LeCouf because you already mentioned them and kind of what they said, and they weren't actually providing an alternative account of the effectiveness of mathematics. They were just describing, they were explaining. Go ahead.
In fact, they quite disagree with his view, Stephen's view, that the universe is not characterized by this elegant mathematical structure. All of them believe that it is. In contrast to Stephen's sort of conventionalist view.
All right, so let's get to the next clip, which includes a concession from Stephen, and it also includes an Einstein quote. Let's watch.
First, a great deal of mathematics in science cannot be physically realized. For example, imaginary numbers and infinite dimensional spaces.
Indeed, much of mathematics can't be physically realized, and it's for this reason that while I recognize mathematics to be one of humanity's greatest tools, I do not assert that all that we can infer from its axioms necessarily exist in reality. To quote Einstein, as far as the laws of mathematics refer to reality, they are not certain. As far as they are certain, they do not refer to reality.
So my question is, where does that Einstein quote come from?
It comes from an essay on sidelights on relativity. And if you look at the context, again, of the quotation, Stephen has just misinterpreted it. It's about the different types of geometries that might characterize the physical world. And particularly, Einstein is contrasting Euclidean geometry, which is the sort of plane geometry that we all were taught in high school, with Riemannian geometry, which is the geometry of the surface of a sphere, or Lobachevskian geometry, which is the surface of a saddle. These geometries have radically different properties because of the shape of space. And what Einstein is saying is that for centuries, people were certain that Euclidean geometry was the geometry that describes the physical world. But in fact, that may not be the case. The physical world may be describable by a very different sort of geometry in which space is curved, for example. So I think that the quotation has nothing to do with Wigner's question about the uncanny applicability of mathematics to the physical phenomena, a question that Einstein himself recognized as a great mystery.
What do you think about his initial concession that there is a lot about mathematics that is not applicable to the physical world?
I guess I didn't see it as significant because as I understand Stephen, he doesn't take, he's hard to understand because, as I say, it's kind of an inconsistent mishmash of views. But so far as I understand him, he's not saying what I think is the best naturalist response to Wigner's argument. Namely, the reason that mathematics is applicable to physical phenomena is that the universe itself, the physical universe itself, is a sort of mathematical object. The physical universe itself has a mathematical structure to it, and therefore mathematics will be applicable to it. This is the view of Tim Maudlin, who is one of the three naturalists portrayed in the video, along with Quine and Russell. And I think that's an important objection, and therefore I give this twofold response. That, first of all, it's simply not true that a lot of the applicable mathematics can be realized in the physical universe. The universe can't have that physical structure. But then secondly, this just kicks the can down the road, because what we want to know is, why does the universe have this elegant mathematical structure that it does. And that is unanswered by naturalism.
So one of my thoughts on this claim that he made, or the concession that he makes, is that it kind of seems to be in tension with something that he said earlier, and he was explaining why mathematics is so effective. He was saying that's because when it's not effective, we alter the axioms, right? He's expressing his conventionalism.
Yeah.
But what we learn here is he concedes that there is a lot in math that is not effective. It doesn't apply to the physical world. And so wouldn't he then say that we would just alter the axioms? We would alter the math in order to be physically applicable?
No, I think that's not right, Cameron. The point is that things like infinite dimensional Hilbert space and imaginary numbers are very useful in describing the physical phenomena. These are applicable to the physical phenomena, but that doesn't mean that the universe itself has this physical structure. Here again, Wigner's essay is so carefully argued and carefully crafted. Wigner does not say that what is amazing or uncanny is the applicability of mathematics to the physical structure of the world. He doesn't say that. He says what is uncanny and unexpected is the applicability of mathematics to the physical phenomena. And I want to emphasize that word phenomena. This is the way the world appears to us. But Wigner is not endorsing a naive scientific realism where every theoretical entity in high-level physics has a counterpart in reality. Much of the mathematics that is applicable in science is instrumental in nature rather than realistic. And the examples I gave would illustrate that. So you can't explain the applicability of mathematics by simply saying that the universe has or is imbued with a mathematical structure like this, because that's not true.
Okay, let's get on to a couple more clips, and then we're going to close this one out. How are you on time? Do you need a...
Well, I've agreed to do an hour with you, so whatever you'd like to do.
Okay, let's just close it out then, because we're at an hour. How about that? So do you have any closing thoughts?
What's the next clip about? Now you've got my curiosity piqued. Let's do one more.
Okay, well then let me pick. So we've got 3 clips left, and I think I'm going to do one where he argues that the theistic explanation is a non-answer.
Yes.
So let's do that one.
Let's talk about that.
Okay, here we go.
By contrast, for theists, mathematics works so well in the physical world because God has chosen to create the world according to the plan he had in mind.
Right, so according to Craig, the answer, mathematics is effective because the universe is relatively consistent, is unsatisfactory. But the answer, mathematics is effective because of God, is somehow perfectly satisfactory. God is a non-answer. It's the equivalent of because I said so. It not only doesn't answer the how element intrinsic to the why question, but it actively shuts down investigation. It stalls progress and rots the mind. When Newton's laws did not account for the trajectory of all the celestial bodies in the solar system, he invoked God, and in doing so turned his brilliant mind off. So far as he was concerned, he had answered the question, but he had not. There was a natural explanation that not only answered why, but more crucially answered how. And the answer, funny enough, required us to alter our mathematical axioms.
Did you notice any of the kind of this sounded to me almost like Peter Atkins?
Well, there's just so many things wrong with what he said, and I just want to highlight again, it did not require us to alter our mathematical axioms. What were revised were the laws of physics, not our mathematics. And what you have here is the manifestation of naturalism in a different definition. We've talked about different definitions of naturalism today. One would be the view that all that exists is space-time and its physical contents. Another would be that there are no miracles, that there are no supernatural causes. A third definition of naturalism is epistemological. naturalism. And this says that our only source of knowledge is the physical sciences, and that therefore anything like God cannot be used as an explanation because it's not an extension of the physical sciences. And I reject naturalized epistemology, as do the three theists pictured in the video, Alvin Plantinga, Mark Steiner, and Michael Dummett. It is a good metaphysical explanation to posit a cosmic intelligence who has designed and created the universe. As Ed Witten said, it's as if the world were created by a mathematician. That is definitely explanatory. And it's not a science stopper, Cameron, because it's not a scientific explanation. It's a philosophical or a metaphysical explanation to a metaphysical question. Wigner's question of the applicability of mathematics to the physical phenomena is not a scientific question. And that's why for someone like Wigner, it's inexplicable. It has no scientific answer. It's a philosophical question, and therefore a philosophical answer is quite appropriate. And therefore, to give this philosophical answer of a cosmic designing intelligence is not a science stopper. Science can proceed unabated if you believe in the existence of a God who has created the universe on this mathematical plan. In fact, if you watch the rest of that interview between Paul Davies and Robert Kuhn that we've seen the clip of, Davies goes on to talk about how this hypothesis might be falsified, and therefore it doesn't stop the advance of science. So I think Stephen here is betraying his assumed naturalism. His naturalistic slip is showing, so to speak. And I would say there's just no justification for that kind of epistemological naturalism.
That was a pretty good line there. His naturalistic slip is showing. So just one quick thought on that, or two quick thoughts, is one of the things that you said is that there's different types of explanation. That goes back to the guy I mentioned earlier, Richard Swinburne. He identifies two different kinds of explanation, scientific and personal explanations. And so in the theistic case, obviously we're talking about a personal explanation, talking about someone's desire, someone's intentions, someone's beliefs. And those are the types of things that we're going to appeal to in a personal explanation, as opposed to a scientific explanation, which appeals to laws of nature. And we can't explain the laws of nature by just saying the laws of nature exist. That's not an explanation of anything at all. So when we get to that level, we've got to go for something else. So we've got to go for a personal explanation. That's one thing. And man, the other thing. Okay, here it is. The other thing that I had that I wanted to say was that when Stephen says that God is a non-answer, and that it shut in theism, or a theistic explanation shuts down investigation, that to me is kind of like shutting down investigation into theism.
That's well said, Cameron. I mean, here we have posed a philosophical problem, and Stephen is going to shut down investigation of that philosophical problem because he doesn't like the metaphysical postulate that it might lead to. And the only way I think he could justify shutting it down would be by the assumption of epistemological naturalism, which is an unjustifiable methodological predisposition and not a worldview that can be rationally defended.
All right, let's leave it there. So thanks, Dr. Craig, for coming on. Do you have any last thoughts that you'd like to say about this video, about Stephen, about what you've seen from him?
Well, just that I welcome the critique. I'm glad to have had the chance to engage with it on Capturing Christianity. And I would again commend to folks Colin Ruloff's book on the arguments of natural theology and my article in the book on God and the applicability of mathematics, where I go into this in much greater detail.
Yeah, and the last thing to note as well is that you did have, and I already mentioned this earlier, but you did have a discussion or dialogue with Dr. Graham Oppy about this argument, and that was very high level. So if you want to get more on this that's already available as free, then just go check it out. It's in the archives of our videos. And the breakdown that we did of it, I highly recommend that as well. It was super great. David even went into his classroom. I think this was before COVID, but he went into his classroom and he filmed like a little experiment to show some of the applicability of math that is just real easy to understand. It was great. So definitely go check that out. But Dr. Craig, thanks for go ahead.
Your interview with David Hutchings, right?
Yes, correct.
David Hutchings.
David Hutchings. Yeah. All right. Well, thank you guys for watching. We will see you in the next Capturing Christianity video. See ya.